Here comes the fourth video of this section, extracting confidence measurements. In the previous video we learned how to deal with class imbalance. In this video we're going to take a look at measuring boundary distances and computing confidence measurements. It would be nice to know the confidence with which we classify unknown data. When a new data point is classified into a known category, we can train the SVM to compute the confidence level of this output as well. Let's see how we can do this. The full code is given in the svm_confidence.py file already provided to us. We'll only discuss the core of the video here. Let's define the input data. This is a line of code to define the input data. Let's measure the distance from the boundary. This is the code to measure the distance from the boundary. Now if we run this code, python svm_confidence.py, so you can see the output. That is the distance from the boundary. The distance from the boundary gives us some information about the data point, but it doesn't exactly tell us how confident the classifier is about the output tag. To do this, we need plat scaling. This is a method that converts the distance measurement into probability measure between classes. You can check out the tutorial at fastml.com to learn more about plat scaling. Now we need to train SVM using plat scaling. This is the code for that. The probability parameter tells the SVM that it should train to compute the probabilities as well. Now let's train the classifier. This is the line of code for that. Next we compute the confidence measurements for these input data points. This is the code for computing confidence of input data. The predict_prober function measures the confidence value. We can see the output. Now let's see where the points are with respect to the boundary. We'll plot a graph for that. This is the line of code to plot the graph. Now we'll run the code. So this is the output you can see on your system. Cool. So that marks the end of this video. In this video we've learned how to measure boundary distance and extract confidence measurements. Great! In the next video we'll take a look at finding optimal hyperparameters.